Hello, welcome back. Today we are going to talk about applying transformations to data. And so we're going to look at those statistics we learned about last time, and we're going to see how they are affected whenever we add a constant to data values and then whenever we multiply a constant across data values. So first we're going to talk about adding. When a constant is added to every value in a data set, the following are true. The mean, median, and mode of the new data set can be obtained by adding the same constant to the mean, median, and mode of the original data set. And the range and standard deviation are unchanged because the distance between values doesn't change. Just the whole data set is shifted. All right, so let's look at an example of this. The data set below gives the weights in pounds on Earth of 8 astronauts without their spacesuits. A spacesuit weighs 250 pounds on Earth. Find the mean, median, mode, range, and standard deviation of the weights of the astronauts without their spacesuits and with their spacesuits. So here we have the list of the original weights. We need the statistics for that data set. So you want to open a document in your calculator and you want to create your list. You can call it weights, or you can call it original values, original weights, whatever you want to call it. And so you would have 142, 150, 155, and then you want to do one variable statistics and go through the list of the one variable statistics. The mean is 158. The median would be 158. The mode is not going to be on your list of 1var stats. You have to figure that out. So if we look, 160 is the only repeated value, so our mode is 160. We can find our range by taking the largest value and subtracting the smallest value. In the list of output for one variable statistics, it will give you the maximum and the minimum. And so you can then use those for to do your subtraction, or you can just look and go, okay, 175 is the largest, 142 is the smallest. So if I subtract, I'm going to get 33. And then if you look for baby sigma, that will give you your standard deviation of 9.3. Okay, great. Now, based on the rule that we just learned, we don't have to go through and add 250 to each of these values and then do 1var stats again. We could, but we don't have to. We're simply going to add 250 to each of the measures of central tendency because every value here is going to move over 250 pounds. We're going to add 250 to everything. The range and the standard deviation won't change, because the difference between the largest and smallest would still be 33. And if you calculated the standard deviation, it would once again be 9.3. Now, intuitively, what that means is that we're not increasing the distance from the smallest to the largest as reflected in the range, nor are we increasing the average distance from the mean, because everybody's being shifted over the same amount. Okay, so the weights with suits, that particular distribution is going to have a mean of 408, because that's 158 plus 250, a median of 408, because again, 158 plus 250. The mode would be 160 plus 250. We'd have two values of 410 in our weight plus space suit list. The range would still be 33. You've added 250 to the max, you've added 250 to the min, so that 250 will get subtracted off when you do max minus min. And then the standard deviation, likewise, won't change at all either. It will still be 9.3. Okay, so let's look at what happens when we multiply. Is it going to be the same thing, or will the range and standard deviation also be affected? The data set below gives the winning distances in meters in the men's Olympic triple jump events from 1964 to 2004. We want to find the mean, median, mode, range, and standard deviation of the distances in meters and the distances in feet. 1 meter is about 3.28 feet. Okay, so our distances in meters, we have our ordered list here. Again, you want to put that in your calculator, do one variable statistics for the things you can do one variable statistics for. And so we've got a mean of 17.53. We have a median of 17.39. Oh, our list is not ordered, so we have to look a little carefully to see what the mode is. Let's see, 17.35 is the only repeated value, so it is our mode. Our range is going to be small. It's the maximum minus the minimum. And so it's 1.32. And then our standard deviation is very, very small. It's 0.37. So here's what happens when you multiply data values by a constant. When each value of the data set is multiplied by a constant, a positive constant. So here we're going to need to multiply by 3.28 to convert from meters to feet. Every single statistic gets multiplied by the same constant. Okay, in this case, when you multiply the smallest value by 3.28 and the largest value by 3.28, and then you subtract, you're going to see that you have increased the maximum amount by more because you're doing 3.8 times 18.17, then you increase to 16.85 because it will just be 16.85 times 3.28. So when you do your subtraction, you'll see that the range is larger. Okay. In fact, it's going to be 3.28 times larger, and the same with the standard deviation. So when we multiply, you just go down the list and multiply everything by whatever your constant is. So our new mean would be 3.28 times 17.53, so 57.5. Our median we multiply by 3.28. Same with our mode, and our range and our standard deviation we multiply by that constant. So when we're multiplying by a constant, everything gets multiplied by that constant. When we're adding a constant, only the measures of central tendency increase. The range and standard deviation would stay the same. Okay, go ahead and do the problems to try on your own. If you need help with it, come in, get some help. Otherwise, I will see you in class next time. Have a good day.